Here we have the equation 1 plus square root of 7 minus x equals x, and we are to solve it for x, give our answer in both exact form and decimal form rounded to the nearest hundredth. So to start to solve this problem, the first step I always do is to try to isolate the radical term. The term that has the radical in it, I want to get it by itself. This term here, being the radical, I want that to be the only thing on this side of the equation. So to do that, I need to take care of this plus 1. Since the 1 is being added, subtract 1 on both sides. So you'd have a 1 being added, you'd have a 1 being subtracted, so basically you'd end up getting addition of 0 there, so it simplifies out. Now on the right hand side, I cannot combine like terms because that's a variable and that's a constant, so I just write x minus 1. At this point I need to undo that radical here, and it turns out that radicals and powers are inverses of each other. So if you ever have the nth root of something and you want to get rid of, so to speak, that radical, one thing you can do is raise it to the nth power. So for my example, because there is no index here, it's assumed that it's a 2. So here the index is a 2, so to undo that I would have to square both sides. So if you let me just take what I've written here and square the left hand side and square the right hand side, the squaring process and the square root undo one another, leaving you with whatever your radicand was. Whatever was under that radical, you need only just copy it. So over here now I have the quantity x minus 1 squared, and if I'm going to solve this, then I'm in the middle of a FOILing problem now, because x minus 1 quantity squared means to take x minus 1 and multiply by itself. If I were to FOIL this, I would have x times x is x squared. You'd have x times negative 1, which is negative x. You'd have another negative 1 times x. You'd have another minus x. And then a negative 1 times a negative 1 is a positive 1. You could combine the negative x and the negative x. That gives you minus 2x. And then you also have a plus 1 there. So trying to get the variables to one side, what I could do is add x to both sides. And on the left hand side, subtracting x and adding x would simplify out. I would just left with 7. Over here I'd have x squared. I have subtracting 2x and adding 1x. That would leave me with minus 1x. And then I still have the plus 1. So at this point I have a variety of methods to solve this. I could use my graphing calculator, I could use the intersect feature, I might use the quadratic formula, or if I'm lucky, this may factor. I'm going to try factoring this. To do that, I would need this set equal to 0. And in fact, if I wanted to use the quadratic formula, I would need this set equal to 0. You're going to subtract 7 then to bring it over here, and 7 minus 7 is indeed 0. Over here, combining the plus 1 and the negative 7 would give you negative 6. So if this is factorable, then what you need to do is sort of the opposite of FOILing. You put an x here and an x here so that when someone started the FOILing process, they'd get x times x is x squared. Usually the last thing done in FOILing is you take whatever you put here and here, and remember that gets multiplied to give you the constant here, negative 6. So we need to find two numbers that multiply to give you negative 6, and it turns out, because there's a leading coefficient 1 there, that those same two numbers have to add up to be your middle coefficient there of negative 1. So numbers that multiply to give negative 6 and add up to negative 1. You simply start writing down different ways of multiplying numbers to get negative 6, like negative 1 times 6, 1 times negative 6. So 2 times negative 3 would work, negative 2 times 3 would work. You need to figure out which one of these pairs, there's only 4 of them, right? 1, 2, 3, 4 pairs. You need to figure out which one of those would add up to be negative 1. And so if you just went 6 and add it to negative 1, you don't get negative 1, you get 5. Negative 6 plus 1 is negative 5. Negative 3 plus 2, this is our guy. If you took 2 and you took negative 3, it has both properties that if you were to multiply them, you get negative 6. If you were to add them, you'd get negative 1. So these are the numbers that go in these blanks here. So if you were to put a positive 2 here and a minus 3 here, that would be a correct factorization. There's a property, they call it the zero product property, that if you multiply two numbers and the result is 0, here is the logic. If you were to plug in an x value, when you add 2, this is just going to be some number here, right? And for that same x value, if you plugged it into this expression, this factor would just come out to be some number, right? You take that number, you subtract 3, you get some other number. So the idea is we don't know what those numbers are, that's what we're trying to find, but we do know that their product is 0, that when you multiply them, you get 0. So the idea is it can't be like 3 times 4. 3 times 4 is not 0. In fact, the only way to multiply two numbers to get 0 is if one of them or both is 0. We will get a solution as long as that thing comes out to be 0. And the other way to get an answer would be if this quantity came out to be 0. So now you've reduced this equation from a radical to a quadratic, basically down to 2 linear factors. So now if I was to subtract 2 on both sides, I get one of my answers is negative 2. 2 minus 2 is 0, so it's simplified out. 0 subtract 2 is negative 2. Over here, if I add 3 to both sides, I get negative 3 plus 3 simplifies out, and over here I get 0 plus 3 is 3. So it turns out with these problems that you should check them. Once in a while you get extraneous solutions. So to do that, what you do is you go back and replace the x's in the original equation with your proposed solution. So think of these are possible solutions, and once in a great while it turns out that one of them doesn't work. So if I was to do my first solution, if I was to replace x with negative 2, I'd have 7 subtract negative 2, and on the right hand side replacing that x with negative 2 would look like this. Now it's just a matter of simplifying to see if I get a true statement out of this. And I get that when you subtract a negative, that's the same as adding. So this is essentially 7 plus 2, or 9. Well, the square root of 9 is 3. So when I plug this in, I basically get the statement that 1 plus 3 equals 2. So you tell me, is the number 4 the same as the number 2? I think not. So it turns out that this is one of my extraneous solutions. We did the algebra correct, but it did not give me a solution to the problem. So I'm going to throw this one out. X equals negative 2 did not work. Now I have to still check the remaining one, and once in a while you do get a problem where the answer is no solution. So if you were checking this graphically, if you were using your intersect feature, you would notice that the curves do not intersect at x equals negative 2, and that would be another way of seeing that it's not a solution. So going back here now, let me check my other answer. I'm replacing x with positive 3. And on the right hand side we have x should be 3. Here you have 7 minus 3 is 4, and then the square root of 4 is known to be 2. So now I get a statement that makes a little more sense. I get 1 plus 2 is 3, and 3 is indeed equal to 3, so it checks. So my only solution for this problem is x equals 3. If you have the patience, you could put this in y1, and you could put this in y2, and you would see that they do not intersect at negative 2, that there's only one place of intersection, and they would intersect at x equals 3.